Okay, so this is section 8.1. It's all about parallelograms. Okay, so what is a parallelogram? Well, it's a shape that is made up of two sets of parallel lines like this, right? And today we're going to talk about these four conditions of a parallelogram and prove to you why these four properties of a parallelogram are true. Right? The first one is that the opposite sides of a parallelogram are congruent. Okay, so this is showing that A and B is parallel to C and D, and A and C is parallel to B and D. Right? These are little arrows instead of like parallel marks, so they're not confused with congruent marks. Okay, so the first thing I want to do is I'll zoom in here on B and this parallelogram here, and I'm going to make a triangle, two triangles. I'm gonna draw a connection between A and B right here. I'm sorry, A and D right here. I'm gonna mark these angles as triangle 1, 2, 3, and 4. Okay, so I got triangles 1, 2, 3, and 4. And we can say right off the bat that this triangle ABCD, or that this quadrilateral ABCD is a parallelogram, right? So that this is a parallelogram, right? And that's given. That's given. All right. So if that's a parallelogram, that means that A and B is parallel to C and D, and that A and C is parallel to B and D. B and D, that's the definition of a parallelogram. That's the definition of a parallelogram. All right, so if that is true, right, so if this is a parallelogram and these are parallel lines, what does that make this line right here? What does that make AD? That means that AD is transversal, right? AD is transversal. AD is a transversal. Transversal, right? That definition of a transversal. And that angles 1 and 4, and angle 1 is congruent to angle 4, because those are alternate interior angles. Alternate interior angles are congruent. Not only are 1 and 4 congruent, but angles 1 and 2 and 3. Angles 2 and 3 are congruent. Angles 2 is congruent to angle 3. Angle 3. Okay, so that we have, so I'm going to say that this angle and this angle are congruent, and this angle and this angle are congruent. Okay, well, so that's true. And I also can say that, let me zoom out maybe a little bit. Well, I guess it's as little as I can zoom out. I can also say that angle SD, or AD, excuse me, angle AD, line segment AD is congruent to line segment AD because of the reflexive property. Reflexive property, right? So if that's true, then I have these two triangles ADB, a triangle ADB is congruent to triangle DC, or DAC, triangle DAC, because of angle, side, angle. Angle, side, angle. Right? And if that's true, then I can say that the corresponding sides AC is congruent to BD, and CD is congruent to AB, because of my good old corresponding parts of congruent triangles are congruent. All right, so that is that one there. Okay, opposite sides of parallelograms are congruent. Okay, so that marks that one off. Okay, the next one is opposite angles of the paralleling of the opposite angles of a parallelogram are congruent. Okay, well, it's kind of the same proof here, so let's get on that one. Opposite angles of a parallelogram are congruent. All right, so it's kind of the same thing here. We have the same first two there. I'll pause this for a second. Change colors. Okay, so I got my red pen now, and again, we have these two lines here, and we have AB. So we give them that A, B, C, D is a parallelogram, and that's given. And then that means that AB is parallel to CD, and AC is parallel to BD. That's the definition of a parallelogram. Okay, so these are like so these are parallel to these, and these are parallel to these. That means that this is a transversal to these two, and that these are a transversal to these two. Okay, so if these are parallel, is a transversal to this, right? That means that angle BD, or C, I'll just say angle D here. So that angle D is supplementary to angle B, right? Because they are consecutive angles. Okay, and then so we'll make this one an angle 2, I guess, an angle 2. Okay, and then if you turn it this way, maybe zoom in a little. If you turned it this way, you would say that angle A and angle B are consecutive angles as well, because this is a transversal of these two, right? So if you have angle A is supplementary to angle B because of consecutive angles. Okay, so now you can say that angle A is congruent to angle B because of the congruent supplement theorem. Congruent supplement theorem. Right? Because you have two supplementary angles, right? It says that two angles that are supplement to this angle are congruent, right? So this is supplementary to this is supplementary to this, so that these two angles must be congruent, right? And then you can say that angle C is supplementary to both angle A and angle D because they're consecutive angles. Let me zoom out a little, right? And then you can say that angle. Now you can say that angle C, angle B, you can see angle B is congruent to angle C because of the congruent supplement theorem. Okay, so that is that one. All right, so moving on, let's check this one off as complete. All right, so the next one, let me go ahead and pause this one in case I have an error. Well, I guess the next one we should have done first, but that's all right. All right, so the next one is consecutive interior angles of a parallelogram are supplementary. And this one is kind of fairly intuitive, right? So if these are transversals, right? So these are transversals of each other, and these are transversals of each other. Okay, right? That means that, so these are the same. Right, so that means that angle, we'll say this is right, so these are transversals. So that means that angle, that line AC is a transversal of parallel lines AB and CD, and then you can say that line CD is a transversal of AC and BD. Okay, so these are transversals of these, and these are transversals of these. Okay, so if these are transversals, parallel lines, that means that angle, we'll say angle ACD, angle ACD is supplementary to angle CDB, because they are consecutive angles of a transversal, right? And so on and so forth, right? So you can also say that angle CD, we'll say CDB, angle CDB is supplementary to angle DBA, right? Is supplementary to angle BAC. Right, so because these are all interior angles, right, they're all supplementary to each other. Right, this is supplementary to this one. This one's supplementary to this one. This one's supplementary to this one because they're all transversals. Okay. All right, the last one, the diagonals of a parallelogram must bisect each other. Okay, so we have two triangles made up, one made up like this, and the other one made up like this. Okay, so similarly, like to this one, we have alternate interior angles here and here, right? And alternate interior angles here and here, right? So that proves that triangles A, and then we have AD. So I'm just going to say triangles 1, 2, and 3 and 4. So angles 1, 2 are congruent. I'll just do it this way. Angle 1 is congruent to angle 2. Angles 3 is congruent to angle 4. To angle 4. And then we have and then we have AD. We have AD. AD is congruent to AD, just like we did over here. Okay, so you can say that. So you can say that triangle ABD is congruent to triangle DCA. Okay. So because of the angle side angle congruent theorem. Angle side angle congruent theorem. Okay, but similarly, you can say, and then now you can say that you'll be able to say that these line segments are all equal. So AC is congruent to BD, and AB is congruent to CD. All right, but now you can also say that you have this midpoint here. You also have this intersection here, so you can now say that we have these angles here and here. So you can say that angle A, we'll say this is A, B, C, D, this is point E. Okay, so you can say angle AEC, angle AEC is congruent to angle BED, or angle DBE, excuse me, angle DEB. Right, so now, and then now you can say that angle, so that triangle ABD, AEC is congruent to triangle DEB. So these two triangles are now congruent because of angle side. So now these are, so now you can say that triangle, that line segment CE is congruent to BE, and that AE is congruent to ED because of corresponding parts of congruent triangles are congruent, right? Because these are the same line segments of these other two triangles. Okay, so that's how you prove that all of these different theories or properties of these parallelograms are true. Okay, hopefully that works out for you and helps out with help you memorize or remember these properties of these parallelograms.